All right, hello everybody. So this is your second video on inverses of matrices. So I want to point out there's another type of matrix called the identity matrix. And these are square matrices that have ones in the diagonals, so you can see here, and zeros everywhere else. So this is kind of important for telling if something is an inverse or not. Now we're not going to be worrying about the 3 by 3s, but we are going to be worrying about the 2 by 2s. All right, so you've already learned how to find the inverse, but you might be asked, is one matrix an inverse of the other? So this is where this will be helpful. So if you multiply a matrix by the identity matrix, you get that same matrix back. This is like 5 times 1 equals 5. That's the multiplicative identity. So this is kind of the identity for matrices. So notice if we multiply two matrices together and end up with the identity matrix, that's telling us that we have they are inverses of each other. So that's another fact that you might want to keep in your brain for the ACT. So the steps to finding the inverse is always find the determinant first. If you get 0 from the previous video, you already know that the determinant value goes on the bottom in our denominator, 1 over the determinant, so we can't divide by 0. And then that we swap and multiply the other terms by 1. So you already have all that from the previous video. So I just want to make sure we understand what we're doing here. So we calculate the determinant. 3 times 2 is 6. Minus -5 times -1 is 5. 6 minus 5 is 1. So we put 1 over 1. We swap these two values, and then we change the signs of these two values. Oops, moved it. And then we would distribute whatever's on the outside through to everything. So you guys have learned how to do this by hand. And it's not hard to do it by hand. But maybe you want to do it on a calculator. So I haven't actually tried it on here yet, but I bet it's going to work. So what I'm going to do is I'm going to type in a new matrix, and we're going to put in the example that we just looked at. So what I'm going to try doing is say, well, let's use matrix C, and let's raise it to the power of -1. Because that means inverse. Notice we got our answer out. So the calculator can make short work of finding the inverse. And again, let's do the TI-84 as well. So I go alpha zoom to bring up my matrix dimensions, and you make it a 2 by 2. Remember, can't calculate inverses of non-square matrices. So I'm going to type this all in. 3, -1, -5, and 2. So once I'm going to hit right again and get outside of there, and then I'm going to raise it to the -1 power and press enter. Notice it does it all for you.